So the last property we're going to talk about is the distributive property. And the distributive property says if you have a number that you want to multiply by some things inside the parentheses, that you can distribute. So you can go a times b and then a times c. And it also works if the thing you're distributing is in the back. So sometimes they'll show this as well, that you can distribute this way as well. And that can be handy sometimes to have it at the back, so I'd like to cover that. So that's how the distributive property works over addition, but you can also have it over subtraction. So if you have a times b minus c, that's equal to ab minus ac. And the same thing, it could be in the back, what you're distributing, and that would be AB minus AC. Okay, so that's the distributive property, really important property. So here we go with some examples. So we're going to take, we have 6 times x plus 7. We're going to go 6 times x, which is 6x. And then we're going to go 6 times 7, so it's going to be plus 42. And then that's going to be the answer. We can't combine 6x and 42 because they're not like terms. All right, over here on example 7, we're going to go 6 times 5 over 6y, so 6 times 5 over 6y. You can put that 6 over 1 if you want to, plus 6 over 1 times 1/2. Well, here we can simplify, right? So the 6's cancel there and we get 5y. And then 2 goes into 6 3 times. 3 times 1 is going to be 3. So our answer is going to be 5y plus 3. And then we have decimals in the next problem. So we're going to go 100 times 0.04 plus 100 times 0.35d. Now you might say, well, why can I multiply that when it's times d? Well, we'll get to that. But okay, so the first part is those are just numbers. So it's a power of 10. So you're just going to move it 2 decimal places, and you're going to get 4. So you're moving that decimal 2 places because you're multiplying by 100. And why can you do that on the next problem? Why can I do 100 times 0.35 even though the d is attached? Well, it has to do with that associative property of multiplication that we talked about before. So you can go 100 times 0.35. I'm not going to rewrite it, but you're going to move that decimal 2 places, and we're going to get plus 35d, and that's okay. If you wanted to write 35d plus 4, you could because addition is commutative, but I'm not going to bother. Okay, so our next example on 9, we've got a negative. Now you got to make sure you distribute that as a negative 7. So think negative 7 times 8, which is negative. You know, I'll write it because I did the other ones. And then you have to think minus negative 7 times 15y. Now, you could write it that way. There's nothing wrong with that. I don't know if I would write it that way. I would probably just do the multiplication and write the answer, to be honest. But I wanted to show you a way that you could write that. So you might have a question on that. So that's negative 56. And then this is going to be minus a minus, so it's going to be plus. And then I have to figure out what 7 times 15 is. I think it's 105. Yes. And then there's the y there, so 105y. And that's going to be the answer. Again, they're not like terms, so you can't combine them. All right, so we have a couple more examples here. Number 10, that's a really important one because for some reason it gets students sometimes, but it's the opposite of what's in parentheses. But you can think of it as a lot of times students like to put like a little 1 here, so they have something to distribute. But it's going to be the opposite of z plus 11. Now, how did I get that to be plus 11? Because negative 1 times a negative 11, or negative 1, or minus negative 1 times 11. Anyway, it's going to be positive. You're going to have the 2 negative signs, and that's going to work. Now, what I have a tendency to do is I look at this number not as an 11, but as a plus a negative 11. So I change things in my head to adding the opposite, and that makes it a little bit easier for me. Okay, the next problem sometimes causes confusion. You have to follow the order of operations. So if you're dying to go 9 minus 3, don't do it, because in the order of operations, multiplication comes before subtraction. So we have to actually do this distributing that we're talking about first. And we're not going to distribute 3, we're going to distribute a negative 3. So it's going to be 9 minus 3x minus 6. So you can think about that for a minute, but negative 3 times x, negative 3x, or minus 3x. Negative 3 times 2 is negative 6 or minus 6. If you want to write plus a negative 6, you could do that as well. But here's the thing. This time we can combine. We can combine the 9 and the minus 6 because those are like terms. So we're going to get 3 minus 3x. So that's a good problem to do. I'm sure there'll be some in the homework. So you want to practice that concept. We have something similar on this last one. We're going to distribute the 8, and it just goes to what's inside those parentheses. So we're going to get 8x minus 8. And then I have to distribute this minus, or think of it as a minus 1, minus x minus 5. This is how I would do the problem. You might have another way that you like better that would get you the right answer, but that's what we want, is the right answer. Okay, now there's stuff I can combine. So 8x minus 1x, that's going to be 7x. And then I have a negative 8 and a negative 5, that's going to be minus 13. And there you go. That's another good problem.